Hello guys. I have interesting topic, or we are continuing an interesting topic of Euclidean geometry. Today we are looking at the theorem. Uh, Let me go a little bit. I want to talk about, yes, angle at the center of a circle subtended by the chord is twice the angle at the circumference subtended by the same chord. Most of the time in your book, they will say to you, angle at the center of a circle subtended by the arc is twice the angle at the circumference subtended by the same arc. So I prefer to say chord. I prefer to use the word chord. So we are going to look at this theorem that says angle at the center is twice the angle at the circumference. Let's say we have got a circle. Boom, that's an ugly circle. Sorry. Then we have a center here. So let's say we have got an angle at the center. Let me call my center O. This angle here is the angle at the center. And if you look at this angle at the center, it's very important to identify what is subtending your angle at the center. In this case, I will say A, B. So the angle at the center here is subtended by the arc AB, or one can say the angle at the center is subtended by the chord AB. It's very, very important to understand what I'm talking about. This angle at the center is subtended by the arc AB. If you look at these two lines that form the angle, this line and this line, you look at this line comes from the point A at the circumference, and this line comes from B at the circumference. So I will say my angle at the center is subtended by AB. Now, this angle at the center is twice the angle at the circumference. So let me create another angle at the circumference like this. Let me call it perhaps C. Let me just say it's C. So this angle at the center, angle O, is twice angle C. What is important is to see that they are both subtended by AB. You can see AB as an arc, or you can say AB as a chord. If you look at the line that formed angle C, it's very important. You look at the line that formed angle C. This line comes from A, and this line comes from B at the circumference. So we say angle C is subtended by AB, and angle O as well is subtended by AB. So we say this angle at the center is twice the one at the circumference. Angle at the center subtended by the arc is twice the angle at the circumference subtended by the same arc. Let's say I have a circle and I have the center. So this is O, this is O. This means that this angle is the angle at the center. This angle at the center, remember, is twice the one at the circumference. But be careful. Let me do this. Let me create another angle at the circumference like this. Let me say this is C, A, B, D, E. This angle O is the angle at the center, but this angle O is not twice angle C. It is not, even though C is at the circumference, yes, the angle O is not twice angle C. Why? Because they are not subtended by the same arc, or you can say they are not subtended by the same chord. You look at what subtend O, watch out. It's A, B. What subtend angle O is the arc AB. Let me show you what is an arc. The arc is this portion of a circle. Yes. So you look at angle C. Angle C, yes, is at the circumference, but it's subtended by D, E. So in this case, O is not twice C. For the angle at the center to be twice the one at the circumference, the angle at the center and the angle at the circumference, they must be subtended by the same arc, or they must be subtended by the same chord. So we know that the angle at the center is twice the one at the circumference. What I want us to do now, I want us to prove that indeed the angle at the center, it is twice the angle which is at the circumference of a circle. So now we are going to prove that the angle at the center, so let me create a circle. Let me say here I've got the center. This point here is my center. So let's say I have the angle at the center. Let me call this center O. And let me say I have the angle again at the circumference. So we are claiming that this angle at the center, it is twice. This angle at the center, it is twice the one at the circumference. So we need to prove, we need to show that indeed the angle at the center, it is twice the one at the circumference. So what I'm going to do, let me say let me say this is C, this is A, this is B. What I'm going to do, I'm going to construct a line CO. I'm going to construct a line from the circumference C going to the center O. That's the first thing that I do. I construct the line and extend. Very, very important. You join the line C from C to O and extend a little bit. Then what I want you to do, I want you to say this is 1, this is 1, and this is 2. I think I need to make some, let me erase, I don't want you to get confused. You create a line. Remember I said you must join a line CO and extend. So what I want you to do, I want you to write 1 this side. 1. What's happening? You write 1, you write 2. You write 2. This thing. You write 2. You write 1. You write 2. You write 2. You write 2. So remember this line is extended. Yes, you construct the line CO and you extend that line a little bit. After you construct the line CO and extend, I want you now to pay attention to the angle which I call O1. I want you to pay attention to the angle which I call O1. This angle, this side O1, this one, this angle here, you have to see that the angle O1 is equals to the angle C1 plus the angle B. We say this is the exterior angle of a triangle is equals to the sum of the opposite interior angles. The angle outside, in this case is O1. In outside which triangle? This O1 is the exterior angle of a triangle, is the angle outside the triangle. So you need to check, is the exterior angle of which triangle? Is the exterior angle of a triangle COB. Very, very important. You have to identify the triangle we are talking about. I'm talking about this triangle here. This triangle here. So I'm saying this angle O1 is the exterior angle of a triangle COB. Is outside, and the exterior angle of a triangle is equals to the sum of the opposite interior angle. If you take the exterior angle of a triangle, you will realize that is equals to 2 angles inside a triangle being added. Let me show you this side here, what I'm talking about. If this is a triangle, no, yes, it's a triangle. Okay, Pay attention to this triangle. This is our triangle. This one is 60 and this one is 50. So I can be able to tell what is the value of x. You look at the angle x is the exterior angle of a triangle. Is outside this triangle. Let me call it triangle A, B, C. Is the exterior angle of a triangle. So this exterior of a area angle of a triangle is the sum of the two opposite interior angle. You leave this angle closer to x. You leave this one. You say x equals to 50 plus 60. So x equals to 110. The angle outside the triangle is equals to the sum of the opposite interior angle. You need to remember this, guys. The angle outside the triangle is equals to the sum of the opposite interior angle, which is what I have applied here. O1 is equals to C1 plus B. O1 being outside the triangle is equivalent to two angles inside being added together. You leave the angle closer to O1. You leave this one out. So you say O1 is C1 plus B. Now, what you do now, you have to realize that OC and OB, these two line segments, OC and OB, they are equal. OC and OB, they are equal. So you say OC is equals to OB. Why is OC and OB equal? Because both they are radius. These are the equal radii. All radius are equal. OC and OB, they are both radius. Why do we say OC is a radius? Because it's a line from the center O to the circumference C. A line segment from the center to the circumference is a radius. I'm referring to this line OC and this line OB. They are both radius. So OC and OB, they are equal. They are equal radii, which makes the triangle COB an isosceles triangle. This side and this side, in the triangle OCB, the two sides becomes, they are equal actually. We say this triangle COB is an isosceles triangle. An isosceles triangle has got two sides that are equal, and it has also two angles that are equal. So in this triangle COB, there are two angles are equal. And which two angles are equal? In this case, it's angle C1, which is equals to angle B. Why? Okay, guys, let me put this isosceles triangle here. Let me try to write it here. This is COB. I set this side and this side are equal because we saw that OC and OB, they are both radius. Yes, they are both radius, they are equal radii. So I will ask you a question. Which angle is opposite to the side CO? There is an angle which is opposite to CO. The angle which is opposite to the side CO is the angle B. Which angle is opposite to the side OB? Which angle is opposite to the side OB? The angle which is opposite to the side OB, it's angle C. So in this case, the angle C is equals to the angle B. In an isosceles triangle has got two sides that are equal and also two angles that are equal. I want to show you a better way of seeing, a better way of finding angles that are equal. I want to show you another better way. In this case, this is C1, okay, B, and this is one, it's O. I said this side equals to this side. So if you want to know the angles that are equal inside an isosceles triangle, I advise you to go to the third side of a triangle, leave those two sides that are equal. Leave out CO, leave out OB, go to the side which is not equal to any of those two sides. Go to the side CB. Remember, OC and OB are equal. Leave those two sides that are equal. Go to the side which is not equivalent to any of these two. Go to this side CB. The angles that are found on this side CB, it's angle B and angle C1. Those angles are equal. So yes, C1 equals to B. So when you go to this isosceles triangle, when you go to the isosceles triangle COB, this isosceles triangle, you realize that the side CB is the third side. OC equals to OB. Leave these two sides that are equal. Leave OC and OB. Go to the third side of a triangle, which is side CB. Now, the angles that are lying on the side CB, they are equal. Which angle? It's C1 and angle B. These two angles, C1 and angle B, they are equal. So when you give a reason, what is the reason? Why are we saying C1 is equals to B? You say these are angles opposite equal side. Opposite equal sides. The angles that are opposite equal sides are also equal. The angles that are opposite equal side are also equal. Yes, sir. Angles which are opposite equal side are also equal. So let's say we have got, I want to show you again. Let's say we have got an isosceles triangle, and this side equals to this side. Let's say it's A, B, C. How can we find angles that are equal? Go to the third side, leave outside that are equal. You see AB is equals to BC. So you leave those two sides, you go to the third side. On the third side, angles that are lying on this first side are equal, which is angle A in this case and angle C. And what's very important is to see that these two angles, they are opposite to the side that are equal. The angle A is opposite to the side BC. The angle C is opposite to the side AB. So we say angles that are opposite to equal side in isosceles triangle are equal. So that's why we conclude that the angle C1 here is equal to the angle B. These angles are opposite to equal side. Now what you do, guys, I want you to go back to your first equation. Remember, in your first equation, you said O1 is equals to C1 plus B. So what I want you to do, I want you to say O1 equals to C1, replace the angle B with C1. Substitute angle B with C1 because we said B and C1 are equal. So where we see angle B, we can go and put C1. We substitute B with C1 because angle B and C1, they are equal. Now your equation becomes O1 is 2C1. You add C1 with C1, you get 2C1. So the angle O1 is twice the angle C1. It's very important now to go back to our diagram and see which angle we are talking about. This is the angle O1, the angle here, O1, the exterior angle of a triangle actually. We are saying this O1 is twice the C1. And the same idea will be applicable to the angle O2. This side will also be equals to 2C2. O2 is 2C2. O1 is 2C1. Therefore, O2 also will be 2C2. So what you now do, you say similarly, in the same manner, similarly, you say O2 is 2C2. You do not need to show any calculation why you are saying O2 is 2C2. This O2 here, why we are saying is 2C2, you don't need to show calculation. The only calculation you have shown is that O1 is 2C1. Now you can, what you do now, you add your angles, you add this O1 and this O2, you add these two angles. You say O1 plus O2. Why do we add these two angles, O1 and O2? Because actually O1 and O2, if we go to our diagram, O1 and O2, this is the angle at the center. O1 and O2 makes the angle at the center. And remember, we want to prove that the angle at the center is twice the angle at the circumference. So I add O1 and O2, which is my angle at the center. Now I say O1 plus O2 equals to, remember we said O1 is 2C1. So I will say O2C1 plus, remember we said O2 is 2C2. Then what happens? O1 and O2, I told you that is your angle at the center. You can call this angle at the center, actually you can call it AOB. It's angle O at the center. Is this whole angle here. The sum of O1 and O2. They make angle O at the center. We say AOB, the angle O, which is equals to 2 is the same, you factor out, you take out 2 as a common factor. So you say C1 plus C2, which means that the angle AOB is equals to 2 angle C, and the theorem is proven. We have proven that the angle at the center of a circle, it is twice the angle at the circumference of a circle. You have to remember this theorem, guys. The angle at the center of a circle is twice the angle at the circumference of a circle. Check if she replies. Just check if she replies, so that I can send her the link. Sorry guys, I had to respond to someone. Let's come back to our maths class. But the theorem is proven that the angle at the center is twice the angle at the circumference. I want to show you something, guys. Let's continue. We are still on the what you can check first. Oh, no reply. It's fine. She will check if she wants to. Yeah. Sharp. All the best. Guys, I want to show you something. Remember, we are still focusing on the angle at the center is twice the one at the circumference. So what we were looking at is this. I will show you the situation that we were looking at. Not so long, we had this kind of situation. This is a circle. This is the angle at the center. We had this kind of a situation like this one, where we were looking at the angle at the center, and we were saying this angle at the center is twice this angle at the circumference. But I want us to look at another possible situation. We are still looking at the same theorem, but there is some trick. Something is different here. Let's say we have got the angle at the center, and we have the angle at the circumference. But if you look at the line that forms the angle at the circumference, somehow intersect the line which was making the angle at the center. There is some intersection. Okay, let me highlight this. Yes, there is a sort of an intersection here. which we did not have in the first situation. This can be a very tricky situation where you have to prove that the angle at the center, it is twice the one at the circumference. Still here we still have O. Let me say A, B, C. It's important to see that the angle at the center, which is angle O, I want a pointer. The angle at the center, which is angle O, the angle here is still twice the angle at the circumference, which is the angle C. Why? Because you look at the angle O is subtended by the line which comes from A and another line which comes from B, which is the same with the angle C, is still subtended by the arc AB. The line that forms angle C, this line comes from A and this line comes from B. So we say actually the angle at the center, which is O, is subtended by arc AB. The angle at the circumference C is still subtended by the arc AB. So the angle at the center is twice the one at the circumference because they are still subtended by the same arc. So we need to prove even here that indeed the angle at the center is twice the one at the circumference. So what you do, you still construct, you still join the line CO. You construct, you join the line CO. It's a straight line. It should be a straight line, guys. I'm sorry it doesn't appear to be a straight line, but it should be a straight line. Let me erase and try to create something better. So let me say I want to create a straight line. It should be a straight line. I'm joining the line CO and I want to say this is 1. Yes, actually I have few angles here. I have 1. I can even say maybe this one is 2. For clarification purpose, 2. I can say this one is 2. Sorry, is 2. This one is 3. It doesn't. I wanted to say this other side. This angle is 3. I'm facing difficulty writing 3. Just know over here we have a fat angle. An ugly 3 is there. So now we still need to prove that O2, actually we are required to prove that the angle at the center, in this case I'm saying it's O2, that it is twice the angle at the circumference, which is C. So how can we do that? It's very important. We are going to use some ideas of exterior angle of a triangle. They are very, very, very important. This idea of exterior angle of a triangle, it's very, very important. I want us to look at the triangle. Which triangle are we looking at? I want us to look at the triangle OAC. This triangle here. I'm trying to create it. You see where my pointer is moving, there is a triangle there. And outside this triangle, there is an angle O1 here. There is an angle O1, which is the exterior angle of a triangle. And I said to you, the exterior angle of a triangle is equals to the sum of the opposite interior angle. So in this case, it means that the angle O1 is equals to, this is what I see, the angle O1 is equals to the angle A plus, I will normally prefer to write 1, 2. Yes, 1, 2. I prefer using numbers. So actually we are proving what O2 is 2C2. We are proving that the angle O2, whatever that, we are proving that the angle O2 is twice angle C2. Yes. So I'm saying angle O1, which is the exterior angle of a triangle OAC, angle O1, it's A plus C1. Angle O1, it's A plus C1. And you look at the same triangle OAC, we still have OA, which is a radius, and we have OC, which is a radius. So OA and OC, they are equal. OA equals to OC. These are the equal radii. And you can remember then I said if you have two sides that are equal in a triangle, that triangle is an isosceles triangle. It will have two sides that are equal and two angles that are equal. And which angles are equal in this case? Since OA equals to OC, since the side OA is equal to the side OC, I want us to leave these two sides. Leave out OA, leave out OC. We are going to focus on the third side of this triangle. We are going to focus on the side AC, this side here. Which angle do you find in the triangle which are lying on the side AC? Is the angle A and the angle C1. So we can say A and C1, even here, A and C1 are equal. A equals to C1. Why is A equals to C1? These angles are opposite equal sides. These two angles, they are opposite to the equal side. The angle A and the angle C1, they are opposite to equal side. So now we can say angle O1 is actually twice C1. Why? I will say O1 equals to C1, angle C1 plus angle C1. You can see what I've done here. I've actually substituted angle A with C1. O1 is still O1. This C1 is still C1, but I've substituted angle A with C1 because I said A and C1 are equal. So I have a right to substitute angle A with C1. In this equation, I have a right to say where I see A, I put C1. So now you have O1, angle O1, which is twice angle C1. So the angle O1, it is twice the angle C1. Okay? So now we know, remember I said most of the time we make use of isosceles triangles when we proving this theorem. So I want us to now focus on the triangle COB. I'm going to put my attention to a different triangle now. Now I'm going to put my attention on triangle COB, this one, COB. If you put your attention to the triangle COB, you will see the exterior angle of that triangle, which is in this case, your exterior angle is made up of O2 and O1. The sum of O2 and O1 is the exterior angle of which triangle? Of this triangle COB. Let me try to, to show you the triangle. Yes. This triangle COB, O1 plus O2 is the exterior angle of that triangle. And we know that, let me write that one, O1 plus O2 is equals to the exterior angle of a triangle is equals to the sum of the opposite interior angle. So it's going to be O1 plus O2 is equals to angle C, which is C1 plus C2, which is C1 plus C2, which is the O2 plus O1, this exterior angle is equals to the angle C, which is C1 plus C2, plus angle B. Remember, the exterior angle of a triangle is equals to the sum of the opposite interior angles. Yes, O1 plus O2 equals to C1 plus C2 plus B. But we know that OC and OB in the same triangle OCB. In this triangle, you know that OC and OB, they are equal. I will put another tick here. So OC is equals to OB because they are both radius. OC equals to OB. These are the equal radii. OC equals to OB, these are the equal radii, making the triangle OBC isosceles triangle. So if triangle OBC is isosceles triangle, there are two angles in that triangle that are equal. In this case is the whole angle C, which is C1 plus C2 is equals to B. So C1 plus C2 is equals to angle B. These are the angles opposite equal sides. These are the angles opposite equal side. In the triangle COB, angle C and angle B are equal. You still remember how we find equal angles in isosceles triangle. So now you can come to this equation. You say O1 plus O2 is C1 plus C2. You can replace B with C1 plus C2 because I said B equals to C1 plus C2. C1 plus C2. Okay, which is the same as O1 plus O2 is equals to 2C1. When you add C1 plus C1, you get 2C1 plus 2C2. Angle O1 plus O2 is 2C1 plus 2C2, which means that we have got O1 plus O2. Okay, let me make O2 the subject of the formula because my focus is on the angle at the center, this one. I want to make it the subject of the formula. So I want to say O2 is equals to 2C1 plus 2C2 minus O1. O2 is now my subject of the formula. Remember, I want to prove that the angle O2 is twice C2. So I want to say O2 is 2C1 plus 2C2 minus, I said something about angle O1 if you still remember. I said angle O1 is 2C1 in this equation. So I can replace O1 with 2C1. Which means that the angle O2 is twice angle C2. Theorem proven. The angle at the center, in this case is O2, is twice the angle at the circumference of a circle. For this theorem to hold, they need to be subtended by the same arc. For the theorem to hold, they need to be subtended by the same arc. So the angle at the center of a circle, guys, is twice the angle at the circumference of a circle. You have to remember that. The angle at the center is twice the angle at the circumference of a circle. So if you have got a circle, you have a center, you see that this angle is at the circumference. This angle is at the center, and you see that this angle here is at the circumference. If I tell you that this angle is 30, it means that this angle here at the center is going to be 60. The angle at the center of a circle is twice the angle at the circumference of a circle. If I give you the circle, I give you the center, and I tell you that the angle at the circumference, it has to be at the circumference. It does not need to be outside. Our angle is here at the circumference. If I tell you this angle is 40, this angle is going to be what? 80. The angle at the center is twice the one at the circumference. They need to be subtended by the same arc. You need to remember that. They need to be subtended by the same arc. Thank you so much for having me in Euclidean geometry. Hopefully you are enjoying my lesson. If you enjoy, make sure that you subscribe, you like, and you also comment.